Day 14. Explain databases like storytelling. Imagine a library. In the library, there is no catalog and anything, but there are lots of books. There are tons of books that you can see, but you need one specific book. How can you find it? If there are millions of books, or even billion, can you find it? Maybe in your lifetime? I think you cannot do that. So, another example, imagine a data warehouse. Imagine a store where you have your food, you have juices, spices and other things, but everything is mixed. So you need to take 5 juice, diaries and other stuff. How can you do that? You would spend your whole day in this store and couldn't find anything. So this is what databases are. But now imagine a library. So you go to library. You have different choices. So you know author name and you can search for the books by this author. You will see all the books by this author in this library. Or you can go other way. You can go ISBN, International Serious Book Number or other stuff. Or you can go by alphabetic order. So you can find the book name in the alphabetic order or with different indexes. So basically these catalogs are the indexes. The same index is the index in the database are these catalogs in the libraries. This is why databases are very important. I would say that they are much more important than software itself, because without software you can get by using database, but without the proper database the software would be pretty useless. Imagine you are searching for the song in your Spotify, but it takes days to find it. So it would be useless, right? This is why databases are very important. There are different types of databases. So depending on how they index the data. So I'm just trying to explain it as if you are not a technical person. This is why I do my best not to use any terms, any jargons, any fancy words. So databases are something like this. You put the things there. It's basically about sorting everything. It's just about sorting. You put everything there and you create indexes. So as we create indexes in the book as a catalog, we say that these are books by this author, these are books by alphabetic name, these are books by genre. So this is the same in database. You can create different indexes depending on how you are going to retrieve this data. If I retrieve this data by, imagine I have a client database. If I need to search for the client by their first name and last name, I can create catalog, i.e. index, catalog, and I can create index by first name and surname. So if I want to do the opposite, surname and first name, of course it's not gonna work this way because I have to create another index like that. So indexes are just basically a card saying that where is the data location. Just I'm coming back to the library analog. In the catalogs are not where data are stored. It's just a pointer. It says that okay, this book is in this shelf, under that shelf, something like that. It shows you the location. Pretty much databases are the same thing. Databases have different types. So there are SQL databases, NoSQL databases, graph databases, column databases, but I don't want to get into these details. These are not suitable for non-technical people. What else I can tell you? And there are different querying languages for database. The most popular one is SQL, which stands for Structured Query Language. SQL was invented, I believe, because they didn't want only programmers use database. They wanted non-technical people to be able to use databases as well. This is why they created SQL. So SQL is very declarative language. Basically, you say that select first name, last name from clients where client's age is greater than 50. So it's gonna give you first name and last names of all the clients whose ages are greater than 50 years. But these days, what I hate is that I see a lot of abstractions on the software part on top of the databases. They create ORMs on top of ORMs or other abstractions. So they are abstracting programmers away from database as if it's a good thing, but I see it's a bad thing, because when you don't know, ORMs are very hard to predict how they work underneath. All the lots of time it can cause n+1 problems. This is why I hate ORMs. I am actually not against them if they are not a lot of abstractions on top of SQL. It's just a small wrapper, just opening connection and handling connection pools underneath, but allows you to write raw SQL queries without allowing SQL injection attacks. This is pretty much okay for me. And I understand why ORMs exist. It's not only about abstracting away, it's also just translating SQL language to programming object-oriented language. But you know, as people abuse everything, now people abuse this one as well. So I see new programmers don't understand SQL. But for me, SQL is much easier than any ORM or abstraction, because you have to learn these abstractions as well other than SQL. So better learn SQL and understand how it works underneath, under the hood. Then you can translate it to anything. For example, when you search for something, let's say in Amazon or somewhere, you just write something, then you put the details of, let's say you buy a laptop. You put the screen size, you put how much RAM you want, how much CPU you want, and these kind of things. And the program has to translate all these to structured query language to query the database for that. So when program tries to structurize, in order to prevent errors of structured programming language, you see a lot of ugly solutions like criteria builders or other stuff, or specification in Java, Spring Boot, in other languages. You can see similar things in ORMs to abstract away. Honestly, I like to do it raw SQL way. Some people might hate it, but it's best you see how you structured your query and you see how it's gonna work under the hood. Yeah, let's wrap up. What is database? Database is just all about sorting, just putting everything together, creating indexes like catalogs, and whenever you need to find something, to make it easier rather than just a garbage, just piled garbage. It's about sorting everything in its place, so whenever you need something, you can find it. That's it for today. See you in the next day. Bye.